this equation today because I don't want to rush to get it done. But I do want to remember these guesses for my speed. And I want to make sure we have this. This is model for my bike speed. This is fantastic, friends. Let's keep this model, try to keep it in your TIs if you can. I don't think you're going to need to erase this on your TIs for the exam for Wednesday, because I don't think you're using data on the exam for Wednesday. And you shouldn't have to do any other data between now and Wednesdays. So let's leave this in there, but I want to write it down too, just in case we erase it. So the model I get is y equals 1.68 x squared plus 2.18x. I'm just rounding these off to 2 decimals. Minus, and this is my favorite part, 0.36. That's my favorite part about using the quadratic. Technically speaking, what should the y-intercept of our model be if it were a perfect fit? If it were perfectly fitting our data, what would the y-intercept have to be? Wouldn't it have to be exactly 0? Because we know the y-intercept of our data is 0. 0, 0. The x equals 0 and the y equals 0. That's damn close. 0.36. 36 hundredths of a second off. You can't even tell by the graph, can you? When you look at the graph, you can't even tell. It looks like it's going through 0. It's damn close. But it's a best fit curve, not a perfect fit curve. Not a perfect fit curve. Is that fair enough? So that's the idea. Now, as to what the individual pieces of that equation mean, you now know what one of them means. One of them is the negative 0.36. That's the y-intercept. That's the predicted value of y when x equals 0. Now, we know it's off a little bit, but it's the least off it's going to ever have to be. What do the a and the b mean? What do you think? If you had to give me a reason as to what a and b meant, what would a and b mean? Any ideas? What a and b mean? This is a tricky question. Kelly, go ahead. Believe it or not, each of them, that's a fantastic take on it. Each of those things have their own units. Now this goes with your second project, which is not due till next week. Dimensional analysis, where you're actually looking at units of numbers and what happens when you combine them. You know, what is y in this model? What is y? Let's not lose the forest for the trees. No, that's x. X is time in seconds. What's y? That's distance in feet. Which is an important part of any model, knowing what x and y are. Kelly, I love what you said. Whatever I do on this side of the equation, when I add all those pieces together, it's going to have to add up to feet. Correct? So, this x squared is seconds squared. I've got to get rid of seconds squared. Somehow. I've got to get rid of seconds squared. Which means I've got to multiply this number times seconds squared to get rid of seconds squared and leave behind in its place feet. So, think about this from a dimensional analysis point of view. If you've got a number here that involves seconds squared, and you've got to multiply it by something that ends up with feet on this side, do you see that this has to have feet in it somewhere? It has to have feet in it somewhere because this doesn't have feet in it. So this has to have feet in it. What else is it going to have in it to get rid of that? It has to have seconds squared in it to get rid of seconds squared. Where's the second squared going to have to be to get rid of the second squared on this side? In the denominator. The units on this are going to be feet per second squared. When you multiply that by second squared, they're going to cancel and leave you behind feet. This feet per second squared is called acceleration. What the hell is acceleration?
How much you're getting faster? How fast?
That was perfectly said. That is perfectly said. How much faster you're getting over time. It's the change in your velocity. It's the change in your velocity. What's velocity then? What's velocity? People are starting to wish they didn't come today. I apologize. Oh my God, why is he asking these questions 5 minutes left to go? What is velocity?
Speed.
It's the speed, which is your change in... Somebody just said it. Distance over time. Distance over time. So acceleration is change in velocity over time. Velocity is change in distance over time. Check out why. That's just for the first power, yes? That would just be seconds. You've got to multiply seconds times some unit to cancel and leave feet behind. Well, that would have to be feet per just seconds. Feet per second, that's velocity! Or miles per hour. You guys use miles per hour. But feet per second. So, to answer your question, Kelly, you actually had it pretty well nailed. This is the acceleration component, which is how much faster you're getting per unit time. This is your velocity component, which would ignore the acceleration and talk about it clearly, linearly. And this is just your starting point. Each part of that equation contributes a little something to it. Kind of cool, huh? And when you have another well, look at that. You say, don't forget about that right now. That. But that's what those three pieces are. The acceleration component, the linear component, and the position component, if you will. We'll deal with all of them next time, yes? Please, Alicia.
I was just curious, on that one, the 2.475 and what's that, 3.7?
Oh, was it 3.7? Did I round wrong, Alicia? Hang on, let me turn it back on. I did, it should be 3.7. You're right, sister. I rounded wrong. Good call. Thank you, my friend. I'm going to try to leave that data in my TI. As a matter of fact, I'm telling you right now, I'm going to put the damn thing in Y0. Don't forget it's there. Because I will. Yeah.